Hello everyone. Today I would like to start new chapter called steam turbine. Now in steam turbine we will learn different topic like classification of steam turbine, then after working of steam turbine, then after different ways via which one can improve the efficiency of steam turbine, then after we will learn some of the thermodynamic correlationship that are useful to design and to analyze the turbine. Okay, so let's begin with new chapter called steam turbine. Okay, so now in today's lecture I would like to discuss only three topics, and that are: first one, definition of steam turbine, then after second one is working principle of steam turbine, and third one is classification of steam turbine. Okay, so let's begin. Now steam turbine, what do you mean by steam turbine? You can say steam turbine is a prime mover which convert the energy of steam into the mechanical power. Okay, steam turbine is a prime mover which convert the energy of steam into the mechanical power. Okay, and that mechanical power we are using to produce electricity. So here you can see the animation of steam turbine, okay, which is continuously rotating, okay, and this rotational power we are using to produce electricity. Okay, so you can say steam turbine is nothing but a prime mover. Okay, so it is all about the steam turbine definition. Now I would like to discuss the working principle of steam turbine. Working principle of steam turbine. So here to discuss the working principle of steam turbine, consider we have a turbine blade like this. Okay, and now assume the steam is coming from the nozzle and directed toward the blade, and it is passing through the surface of blade like this. Here you can see this yellow color particle indicates steam particle. These particles are coming from the nozzle and directed toward the turbine blade, and it is passing over the surface of the turbine blade. Whenever it is passing over the turbine blade, okay, at that time steam will suffer the change of direction. Steam will suffer the change of direction, and because of change of direction, the momentum of steam getting changed. Momentum of steam getting changed, and according to Newton's second law, force is proportional to the rate of change of momentum. So because of change of momentum, here the steam will exert a force on turbine blade, and hence turbine blade will try to move in horizontal direction like this. Okay, so it is the basic fundamental principle for turbine. Okay, now here I have shown only one blade, but imagine we have a wheel. Over the circumference of the wheel we have a number of blade. We have number of blade, and whenever we impart the steam over the blade surface, at that time because of the momentum change phenomenon, the turbine blade will try to rotate about its axis. Okay, for example, here we have rotor like this, and over the rotor we have number of blade like this. Okay, so you can say whenever we impart the steam, the rotor will try to rotate about its axis. So it is basic principle of turbine working, which is based on Newton's second law, that is force is proportional to the rate of change of momentum. Now I would like to brief you about the classification of steam turbine. There are lots of category to classify turbine, but in this session I would like to brief some of them. Okay, first one is according to the working principle of steam turbine, according to operation, or you can say according to working principle. Second one is according to the direction of steam flow, according to the direction of steam flow. Third one you can see is according to the compounding of turbine. Fourth one you can see is according to the pressure, and fifth one is according to the exhaust condition of steam, according to the exhaust condition of steam. Okay, so now let's start with first category, that is according to operation. Okay, according to operation, steam turbine is classified in two categories, namely impulse turbine and reaction turbine. Now what do you mean by impulse turbine and what do you mean by reaction turbine? I think this you studied in your previous semester in engineering thermodynamics. You can say impulse turbine is the type of turbine in which energy available at the inlet of moving blade is pure kinetic energy. Okay, impulse turbine is a type of turbine in which energy available at the inlet of turbine is pure kinetic energy, while in the case of reaction turbine, the energy available at the inlet of moving blade is kinetic as well as pressure energy, kinetic as well as pressure energy. So it is the main difference between both turbines. The energy available at the inlet of turbine is kinetic in the case of impulse turbine, while in the case of reaction turbine it is kinetic as well as pressure energy. Now second difference is that the impulse turbine is the type of turbine in which the pressure drop taken place only in nozzle, while in the case of reaction turbine pressure drop taken place in nozzle as well as in moving blade. The third difference is that from the construction point of view, impulse turbine is quite easy to design, while it's quite complex to design the reaction turbine. Okay, so it is all about the impulse turbine and reaction turbine. The next category of classification is according to the direction of steam flow. According to the direction of steam flow, turbine is classified in four different categories: axial flow turbine, radial flow turbine, mixed flow turbine and tangential flow turbine. Here you can see the classification. Okay, now axial flow turbine means the type of turbine in which steam flow in axial direction. Okay, it follows the axis of shaft, while in the case of radial flow turbine, steam will flow in radial direction. Okay, again radial flow turbine is classified in two categories: inward flow radial turbine and outward flow radial turbine. Inward flow radial turbine means the type of turbine in which steam flow from outside to inside, while in the case of outward flow turbine, steam will flow from inside to outside. Okay, so radial turbine has a two category: inward flow radial turbine and outward flow radial turbine. Next one is according to direction, that is tangential flow. Tangential flow turbine means the type of turbine in which steam flow tangentially to the turbine blade. For example, here we have rotor like this, steam will flow like this, exactly tangentially. Okay. Then after mixed flow turbine, mixed flow turbine is the type of turbine in which steam will flow radially at inlet and axially at outlet. Okay, so it is all about the classification, that is according to the direction of steam flow. Now third one, that is according to the compounding. Now what do you mean by compounding? You can say compounding is the method via which one can reduce the speed of turbine. It is the method via which one can reduce the speed of turbine. Now question, why we need to reduce the speed of turbine? Because whenever we impart the steam over the turbine blade, at that time turbine will start to rotate about its axis with very high speed, or you can say extremely high speed. Okay, and when we are dealing with the extreme high speed, at that time we have to solve all the problem that is related with vibration and balancing. So for the practical use, we need to limit the speed of turbine, and to limit the speed of turbine we are using technique, that is compounding. According to the compounding, we have three categories. First one, pressure compounding type of turbine. Second one is velocity compounding type of turbine, and third one is pressure velocity compounding turbine. Now pressure compounding type of turbine means the type of turbine in which we are dividing pressure into the number of stages so that we can limit the speed of turbine. Okay. Now velocity compounding is the type of compounding in which we are controlling the velocity of steam into number of stages. Okay, or you can say we divide velocity in number of stages so that we can limit the speed of turbine, while the pressure velocity compounding method is the type of method in which we are dividing pressure as well as velocity into number of stages. We are dividing pressure as well as velocity, and ultimately the pressure velocity compounding is the combination of two above discussed method, that is pressure compounding and velocity compounding. And you can say in pressure velocity compounding we are controlling pressure and temperature simultaneously. Okay, so it is all about the classification regarding the steam turbine that is related with compounding. Now next classification is according to the pressure. According to the pressure, steam turbine is classified in three categories: low pressure turbine, medium pressure turbine and high pressure turbine. If the pressure at the inlet of turbine is near about 2 atmosphere, okay, then this type of turbines are called low pressure turbine. If the pressure is in between the 3 atmosphere to 40 atmosphere, then this type of turbine is categorized under the category of medium pressure turbine. And if the pressure is above the 40 atmospheric pressure, then it is categorized under the high pressure turbine. Okay, so it is all about the classification according to the inlet pressure. Okay, now next category of classification is based on the exhaust condition. Okay, according to the exhaust condition, turbine is divided into two categories. First one is back pressure turbine and second one is extraction turbine. Now back pressure turbine means the type of turbine in which steam after the expansion is allowed to flow for particular process. For example, here you can see we have a turbine. Okay, steam is coming from the upward direction like this. As the steam expand and leaves the turbine, okay, so at the leaving point we are supplying steam for the particular process. Process may be any of, for example, heating or pasteurizing, whatever you can say. Okay, so here you can see after the expansion through the turbine, steam is allowed to pass through particular process. Then this type of turbine are known as back pressure turbine, while the extraction turbine is the type of turbine in which the steam is extracted from the intermediate stage and we are sending this steam for particular process. For example, here we have turbine, steam is coming from the upward direction like this and some amount of the steam are flowing toward the condenser, while from the intermediate stage we are extracting certain amount of the steam and we are sending this steam for particular process. Then this type of turbines are known as extraction type of turbine. Okay, so in today's session we have discussed the definition of steam turbine, then after the working principle of steam turbine and classification of steam turbine. So it is all about the today's lecture. Okay, thank you so much.